Hello everyone, let's start. So I will present to you Bob and Alice, from Bob Alice to Verifiable credentials. Once upon a time, there were Bob and Alice. So Bob and Alice are fictional characters that we use in a specification for cryptography or any document. So to not say user number 1, user number 2, they would like to change something. No, we just say Alice, Bob, and we continue with these letters in alphabetical order. So you can look at Wikipedia page, you will see that there is a lot of other characters, but the most famous one were Alice and Bob. So every name that you find there have its own role. Even is an issuer, and it is mnemotechnic a way to find out with the first letter what is your role in the cryptography. So let's, who am I first? I'm Garbaya Walid. I work as technical architect for middleware. I work with these technologies, and I work for Air France KLM, small airline companies. All what I'm going to say is a lie. Please don't go to production with it. Some are approximative things, and it's only my personal point of view. So let's see what we are going to have a look at. Basic cryptography, what are decentralized identifier, verifiable credentials, and let's have a look at the Eclipse data space framework and see how it's working, or how does it apply all of what is before. So some basic cryptography, really basic stuff. So first, why are we using cryptography today? So we use cryptography for confidentiality. If I send you an encrypted message, what I want is no one else being able to read inside it if he does not or her have access to, should have access to it. We use it also for confidentiality, to be sure that no one tampered with the message or this encrypted message or the message that I'm signing for you, so that no one is going to change the content without me knowing and you reading it, knowing it for this. We used also for authentication and non-repudiation. We'll see example afterwards. So the very basic thing that we are all used to is symmetric cryptography. Symmetric cryptography is, you have Alice, she has a key and a message, and she wants to send the message to Bob. So first thing that she will do is sync with Bob about the key. So she shared her password to Bob. Then what she does is she encrypts the message with this key, send the encrypted message to Bob. Bob uses the same key to decrypt the message. If you want to have a look at the mathematics that are underneath, have fun. I don't go into this kind of detail, too complex for me. Basic implementation. Here I'm Alice. I write down a plain text file. The text files are just binaries that we can encrypt, right? So we'll apply an OpenSSL command, give it a password. The password is top secret. Put it inside, as an input the plain text file, have it output as an encrypted message. If you would try to have a look at the encrypted message, it is something that we cannot read, non-useful. We send this encrypted message to Bob. Bob uses exactly the same command, but the other way around, and he puts the exact same password there to decrypt. So let's have a summary about symmetric key cryptography. So for this kind of cryptography, it is nice because it's hard to, if you have an encrypted message, it's hard to open it without the key. You would need either a lot of money, or a lot of CPU, or a lot of time. Pick how you want to do the brute force. Then it is fast to process. So if you want to encrypt something, there exists a hardware implementation of any type of encryption. You push it to a hardware, it will do it pretty efficiently and give you the fast feedback. There is multiple protocols. If you want to stream, means that you don't need to have the complete message before encrypting it. You can encrypt it block by block, or if you want to encrypt it once, all of it, depending on your usage, depending on the type of cryptography you want to do. There is some problems with asymmetric cryptography. As you saw, Alice needed to send first the key to Bob. And this is a complex thing. Either you have a side channel, or you take your car, you go to Bob and you share with him the key. And every time that you need to recycle the key, because yes, we need to recycle our keys every now and then, you have to do this dance again and again, a bit complex thing. So you have this problem of key sharing and the key rotation. If you want to have a look at how AES is implemented, there's a nice video that you can have a look at. It will explain you the mathematics that is underneath with all the bit flipping and so on. Let's try to see how asymmetric key solves part of it. So for the asymmetric key, there is no key sharing needed. So every party, so Alice and Bob, everyone will have a key pair. A key pair is composed by one private key. This private key, you keep it, you never share it. The public one, you can share it with everyone, no problem. And then what we can do with this kind of cryptography, we can encrypt message just like the symmetric key cryptography. But we also can do a signature, so I can prove you that I am the one sending you the message. How it works. So Bob and Alice will have their own pair of keys. The first step is we exchange public keys. And then if I want to encrypt a message, Alice wants to encrypt some message, sorry. She creates a message, uses Bob's public key to encrypt the message, send the encrypted part to Bob, and Bob can unencrypt it with his private key. Then he has the decrypted message. Let's see for digital signature. Digital signature, as I mentioned, is not to encrypt the message, but to prove my identity, to prove that the message is coming from Alice. So we exchange again the public keys. We take a message. Alice uses her private key to sign the message. So she gets a message signature, send this message signature to Bob, and then Bob can verify the signature. As you saw, we had twice having to share this public key. It's less complex than a private key, but you have to do this again. If you want to deep dive in some of the protocols that are underneath, have a look at the RSA algorithm and all the math that is underneath. It is also fun to try to understand this part. So the pros and cons of the public key cryptography. So there is also hardware implementation is not as fast as the symmetric one, but this one has another property is this hardware, you buy it, you will generate the private key inside the hardware, and the private key will never leave your hardware. So if your application is using this hardware to encrypt some message, it will send the message to the hardware, get an encrypted value from it. So you don't need to extract the private key. It is important when if your application gets hacked, there is no way that the hacker can get your private key. There is multiple protocols with asymmetric key also, depending on what you want to do. The disadvantage, it is slow compared to symmetric. You again have a public key sharing problem, so you again have a rotation and something to send. But you have an advantage is this time, this public key, it is public. It is, you can send it by mail, by whatever you want, by any mean you want. It is less complex than sharing a private key, but again, it is sharing something. So let's see how to share with DID or decentralized identifier, how to share at scale public keys. Again, so just to go back to the problem, I have Alice, she has a public key, and she wants everyone to know about it. And especially one case is when you rotate a key. You don't want to take a phone, call Bob and tell him, hey, I rotated my key, please take account this new key. I will be sending you a message with this one. I would like to receive new key, I would like to receive a message with this new key because my key get leaked. So you want to something that is automatic to do this. Here comes the DID. So DID is for Decentralized Identifier. It's a W3C recommendation. So it's not. It is still compared to a draft. It is not an RFC yet. And the idea is how to give you an identifier that point to your public key, and then it will be easy to automate and retrieve the public key faster without having to phone Bob every time. Underneath, what is it? It is just a string. So it is a string, starts with DID, then the implementation, here the implementation of DID is called example, and then you have a unique ID for your identity. So if Alice has one, it will be DID column a method name, the implementation of a DID, and then something for her. And this string can be resolved or converted to a JSON document, and inside this JSON document you will find the public key or the reference to our public key. So that if you change your public key, you just change the document and the ID stays always the same. So if your partner wants to know what is your actual public key, the public key that you are using right now, calls your DID, resolve it, get the document from it, and then it's easier to automate. Sorry. These documents can be hosted on, first they can contain multiple public key if you want. They can also be hosted on blockchains, though that it's complex to modify. It proves that you had this ID in one time, and so on. I told you there is multiple implementation. This is what's called method. So what is a method? A method is, first of all, it's a specification. So you write down a specification. If you want to create a new one, please be my guest, just write a specification that defines these easy things. So first, it needs to be registered so that your name is reserved, like the example one is reserved for example. If you want to create one for Riviera, it will be DID column Riviera DEV. For example, inside the specification, you will have to define how to create, update the DID document, and when to do it, and how to deactivate the DID. And then you will have to define how to do this conversion between this string and this document, how to resolve these two things. So a specification is an easy thing. It is just some, sorry, don't see it. So it is just a document where you have every step that I mentioned. So here you have for DID web, you will have how to create, how to read, how to update, and how to deactivate the key. Let's see one of the implementation of these methods. So DID web, it is registered as DID web. This specification is written on a GitHub page. The format is human readable, I would say, and it looks like similar to a URL. So you will have DID first, the method name is web, and then you have an identifier that is specific to you. And it is liked by implementer because it's easy to do the read function, so the conversion between this and the public key. How to resolve it? So if you read down the documentation, it mentions, hey, to resolve the public key. So we go from this top. This is the DID for Alice. We convert it by removing DID web first. Then we replace the column by slash. Then we add HTTPS in front. And then we add at the end, we append /DID web, DID.json. And she can host, if she hosts this inside this server, and then inside this, at this URL, she puts this public key inside the JSON format, then anyone can just do an HTTP GET and get her official right now up-to-date public key. So we kind of resolved the public key sharing problem, because we can automate now from it. So let's see again. The idea is, so Alice now has a DID on her possession. Send this DID. It will never change. So you don't, if the public key changes, no problem. Bob will resolve it. Get from the resolution a DID document containing a public key, and he will resolve it every so and then. So if there is an update, he will get the update directly. And then she will send her message signature, for example, and he can check the signature without having to share again this public key around. There is some codes on the DID web, because I mentioned it is distributed identity, but here it's just a web server. So some don't like this idea that it is one unique server containing your public key, want it to be more distributed. Then there is other method that uses, for example, as I mentioned, blockchains or other type of storage to put your public key there, and it cannot be stolen. If the server is down, there's no problem for retrieving it. But it's really liked because the simplicity is just an HTTP GET with some formatting that we are often know how to do this kind of call, HTTP call. If you don't like it, just go to the list of the DID extension methods. You will have a lot of methods that implemented DID. So you don't have to stick to DID web. There's a lot of them you can use with public with blockchains I mentioned, or other databases, or yep. And you have an universal resolver. This one, this is a website, but also can be implemented in code. You give it this string, it gives you back the public key. So in this code, in the libs, they implemented all the ways of retrieving keys, doing the resolution. So you don't have to do it by your own. Now that we know how to distribute key, or at least we have an automated way to put the key somewhere and someone can retrieve it from us. Let's see how this applies to verifiable documents and what are verifiable credentials. Bob went to university, Bob got a diploma, congrats. And then Bob now wants to find his first job. Goes to a company, the company asks him, can you prove that your diploma is a real one, not a fake one? With the company, is it because the diploma is printed on some paper and there is color on it, so it is not a fake one? Would the company contact Bob's university? How do they contact them? With a phone again? We thought that we solved this problem of contacting the other party to know if to get a verification. And something else is maybe Bob does not want that the university knows where he's going to be hired. Maybe there is some privacy and concern. So here comes the verifiable credential. It's again a new W3C recommendation. How this would work. It's an easy thing. It's just a JSON document. So you have a JSON document. Inside this document, there's a first part called metadata. These we can ignore. We don't need to understand what is inside it. Inside this JSON, then you have claims. So for example, here we will see that this has been, the issuer is the example university, and the diploma is for www.bob.fr, and we even know that he got a bachelor degree in science and arts. But yeah, well, this is just some claims, right? So how to verify that these claims are true? So you will find a verification method inside the last part, in the proof part, and in this proof part, you will find again a new DID with key there. And this is another method to be able to retrieve the public key that signed this document. And then if you can retrieve the public key, verify that the signature is correct, it means the document is legit. So you don't need to contact, you don't need to send the document to the university to know if he got a real degree, but you can still validate that the document is official and issued by the correct party. So there is other types of verifiable credentials. So we saw this verifiable credential, this pretty basic thing. But you can also have verifiable presentation. It's a way that you have the same document, but the owner, so Bob, can attenuate or hide some claims. For example, if inside this there is a claim, inside the claims there is a claim with the date of birth, maybe Bob does not want to give you his full date of birth. He can just give you the year of birth, and so that you don't. Maybe he doesn't want to leak some information. He can also just remove some claims, and you can still verify the signature of the document. If you want to have a look at this kind of verification, have a look to zero knowledge proof and verifiable presentation. You will have a lot of fun with this. In an enterprise world, how this would work. So to give you an example, the Eclipse data space component is a framework, and in this framework you have two companies, like Devox is one company, Riviera DEV will be another company, and they are all inside one data space. This data space is an association of multiple companies, and inside this association we will have, so we agree that we are going to exchange data. So inside these companies, what we will do, we'll install some components, and we'll see what these components will do. So we will have a central authority, and this central authority will give verifiable credentials, this diploma thing, to every company. Like, you are a company working in tourism, you are a company allowed to manipulate AI conferences. Then you will have a component called Identity Hub that you will install. This one will be there to sync the DID between different companies. It will do all the authentication for you, so you don't think about this part. Retrieving public key from others, just put the component there, it will do it for you. So if a company would like to expose some data, the first thing is to create a component called asset catalog. And with the asset catalog, you put there, I would like to expose the list of conferences that I'm hosting this year. You can also put there, and I would like it to be only visible for companies with this type of verifiable credential, with this claims that the central authority has given. And then you will put a last component is this connector. This connector will do the data transfer between the companies. And then you can exchange data. Just to, so I just installed all this set on my laptop, and if I, let's see, for example, a resolution of a DID document. So I know that I installed Riviera DEV as a component. So if I curl, because I know it's a DID web, so I just have to do an HTTP call on the Riviera DEV. We have to transform the %3A in columns. So this is done, and then we add the port number, and then we have to append .well-known /did.json. I know that I'm going to receive a JSON document, so let's format it. And inside this, I will find, I'll have to verify, because of the method asks me to verify what is the ID that is inside. So this matches the ID that I was looking for. And then I have the public key. I can retrieve I got the public key that was meant to be used for having a conversation with Riviera DEV. If you want to have a takeaway, if you're going to just remember one thing and forget all about the other, symmetric key, asymmetric key cryptography difference is one of them has, the symmetric key have a secret that you need to share. The asymmetric key just work with public key that you can share without any protection. If you always share your public key, never share, always hide your private key, never forget this one. You sign with your private key. and we check the signature with the other's public key. You encrypt with the other's public key, and we decrypt with our own private key. You have to rotate your keys as often as possible, so always think about how to automate this process and maybe use DID web to retrieve public key from other parties. If you are going to encrypt data for long-term storage, think about it twice, because as I mentioned, for example, symmetric key, if you have time, you can decode the content of it, even without the key. Thank you. Questions? No questions? Yep. Yeah, so this is one of the things that are missing in the implementation is how to be sure how does it link to Alice exactly. So, for example, in the DID web, because I'm retrieving Bob is retrieving the DID from Alice, he's calling HTTPS Alice/the DID and so on. So we are protected by the DNS resolution of Alice. Yes. Yes. Yeah. Exactly. I agree. So if we extend it to personal, then you have, for example, imagine tomorrow your ID card, you have a government-issued ID, and this one will be signed by the government and will give it to you. Then if you host this ID inside a web server, someone can check that this ID is by you, and you're the only one to know that it's your property, so you can sign it also with it. So you can do some triangular things. So you ask the government to issue something signed with your key and their key, and then you're sure that your key is yours. It's a complex thing when it goes to scale, but it was one of the, Estonia is doing this kind of giving public keys to personal individuals. Thank you.